Hello everyone. So in the last video, we talked about intervals, inequalities, functions, etc. So in this video, we are going to have a look at generalized method to solve inequalities. Solving inequalities will not come as a direct problem in itself, but it will form a sub problem of a larger problem. So you should be aware of solving inequalities if you want to solve some big problems, right? So yeah. So let's consider an expression f of x is equals to x minus a1 whole power k1, x minus a2 whole power k2, x minus a3 whole power k3, and so on, x minus an whole power kn. Okay, so now what we have is f of x greater than 0 or f of x less than 0 kind of inequalities can only be solved with this method. The first thing we should be taken under consideration. Okay, so these type of inequalities can only be solved through this method. Next thing is you have to arrange these factors in such a way that a1 is less than a2 is less than a3 and so on is less than an minus 1 is less than an. Okay, and coefficient of x should be positive. Okay, and better if it is 1. Okay, I'll tell you why. I'll solve a problem after this, talking about the definition, then everything will make sense. Okay, now the third step which we have to take case is finding out the roots of all of these factors. So for example, all of these factors equate separately to 0 and find out the value of x. So it will come out x is equals to a1, x is equals to a2, and so on. X is equals to a. Now the fourth step is going to be drawing a real axis and plotting all of these roots. So a1, a2, a3, and so on, an minus 1, an, right? Now we are going to start with x greater than an. So if look at this equation now, if x is greater than an, so what we'll have is this this thing will be positive and rest of all of these factors will be positive, because if x is greater than an, by default it will be greater than all of these a's, right? Because of this expression or this condition, right? So this entire expression will be positive. Yeah. So this we are going to draw a straight line representing that this expression will be positive for x greater than an. Okay. Now we hit a root which is x is equals to an. Now at this point, the value of this expression may change, may not change. So how we'll find out? Now kn, this power of this factor will come into picture. Now if kn is an even number, this is an even number, then the value of this factor will have no effect, because even if it's negative, even then this, because of this even power, it will have no effect, right? So in that case, it will have no effect on the sign of the expression. We can continue with the same sign. Okay, now we hit another root, an minus 1. So let's say for example x an minus 1 whole power kn minus 1. This kn minus 1 is odd. Now in this case, the sign of this factor will have an influence on the expression, right? Because this power is odd. So now in this case, when we hit root and the power is odd, we have to change the sign. Again, we have to continue for the next root and check for even and odd and change the signs accordingly till we hit the last root. Yeah. Now we'll get this kind of a structure, this kind of a figure. So now for all those intervals, where the line lies above the real axis, where line rise above the real axis, expression will be positive. Yeah. And rest below the real axis, expression will be negative, right? So this is the way for all these intervals we can find out the value of the expression. Now we are going to take a look at a sample problem in order to for us to understand what's going on. Okay. So now let's check this. Let's say f of x is an expression which is something like maybe x minus 1 whole square, x minus 5 whole power 6, 2x minus 7, minus x plus 2 whole cube. Okay. Now look at this. We have been asked for solving this f of x greater than 0. Okay. So now what we will do is, first thing is, we are going to walk through all of these conditions, all of the conditions which we have written. The first was if we can only solve greater than 0, less than equal to 0 kind of problems, right? So yeah, this f of x is greater than 0. That means we can apply this method, right? So now we have to arrange in the form in the form of that expression form which we have discussed earlier. Okay, so now implies x minus 1 whole square, x minus 5 whole power 6. Now we have to make this coefficient of x, it's better to make it 1, I have told. Take 2 common, so it will come out, it will become 7 by 2, right? Take minus 1 common, so that the coefficient of x becomes positive. So it will come with the cube, and this expression will become x minus 2 whole cube, right? Now what we have is this should be greater than 0. Now positive coefficients, so positive factors will don't have no effect on this inequality, right? So we can get rid of them. Now the negative ones, because minus 1 whole cube is minus 1. So when we multiply minus 1 on both the sides, what will happen is this inequality will get reverted, right? We know this. So this finally this expression will become, or inequality will become, x minus 1 whole square. This is x minus 2 whole cube. This will become x minus 7 by 2 and x minus 5 whole power 6 less than 0, right? Finally, we have to solve this inequality in order for us to get the answer. Yeah. Now, the next step is plotting the real axis and plotting all of these roots, right? So we have 1 here, 2 here, 7 by 2 here, 5 here, right? And we are going to start with the greatest number, 5. So right side of 5, all the factors will be positive and the entire expression will be positive. We'll start with the upside and this will be a plus. Now we hit a root. So we have to look at the power of the factor. So this is 6 and it is an even number. So it will have no effect on the sign. So we'll continue with the same sign. Now we again hit a root 7 by 2. Now look at the power. Is it an odd? Yeah, it's 1, it's odd. So change the sign. Continue. At 2, is it odd? Yes, it is odd. So change the sign. Now continue. At 1, is it odd? No, it's even. Yeah, then continue the sign. Now we have is for x belonging to, so we want this x belonging to 2 comma minus 2 comma 7 by 2, both 2 and 7 by 2 included, because we have added strictly less than 0 condition. If it was equal to 0, in that case we would have written 2 comma 7 by 2, right? Both included. So in this case x belongs to 2 comma 7 by 2, and we are able to find out an interval where this expression is negative and for this expression being positive, right? So yeah, this is all about it. Thanks for watching the video. If you liked it, please subscribe and share with your friends. Thank you.